Good morning, everyone. Thank you for joining, and really excited to be here talking about how we migrated from Airflow to Temporal. I think a lot of companies actually use Airflow for their data pipeline orchestration. And we'll talk about how we made it happen and what did we achieve by doing that. Uh, yeah, this is the talk. Something before we start, something about Noon. So Noon is the leading e-commerce company in the Middle East. We operate in 3 countries: UAE, Saudi Arabia, and Egypt. Started in 2017, and since then it has been the go-to platform for shoppers to shop online. Over over the period, we have launched multiple different verticals. So starting with Noon, which is the traditional e-commerce, Noon Food, which is the food aggregator, and we have Noon Minutes, which is the largest quick commerce company in the region. Uh, we deliver within 10 to 15 minutes to a vast network of our dark stores. We have Supermall, which is again a curated selection of branded products, again delivered to the customers within 60 minutes. We have Now, which gets stuff delivered from your nearby mom and pop stores. Then we have Namshi, which is the fashion marketplace, again, largest in the region. Noon Payments, which is our payment gateway, in-house payment gateway, also doubles up as a B2B, like a company providing services to other clients. And we have Pay, the last one, which we can use to send and receive money from anywhere, anytime. So this is about Noon. Just wanted to give you a quick shout out to the team, Hisham, who is our CTO, who introduced Temporal, actually Cadence initially, to the team, and since then he has been really actively involved in everything Temporal. We have Atire, Hosnu, and Sarah, who are part of the data platform team. We have Jude, who is the lead software engineer, and myself, who I work as an engineering manager. Currently building Noon Minutes, but this project I'm talking about has been my previous project that I worked on. Cool. So before we begin into the actual talk, I wanted to just give you an overview about how our main data pipeline is structured. So we have our Cloud SQL database. We use MySQL, and since we are on GCP, we use like Cloud SQL, which is the managed offering. Then we have Maxwell, which is a change data capture application, similar to Debezium, if you might know that. So Maxwell runs on MySQL and like captures bin log, and we push this data as a JSON into a BigQuery table. So this BigQuery table like acts as an audit log of all the changes that have happened in your source databases. And then we have another workflow that runs like every 15-20 minutes, which gets all the changes that have recently happened on this audit table, and ultimately creates one row per unique record in your source database. So the final data warehouse table actually is like a copy of your MySQL with the lag of like 15 and 20 minutes. It's a very, very easy setup, but it works beautifully well. Anytime a new table gets added, you don't have to do anything automatically because of the bin log. The merge workflow actually takes care of creating the table with the specified schema. If a column gets added, if column gets removed, everything is handled in the merge workflow. So it's a very like a plug and play situation, and it works beautifully with like little to no maintenance. This works runs on Airflow, but we'll talk about that later. So once, say, the data is available in BigQuery, the data warehouse, the natural question is, how do we make it available to all the data analysts and business analysts who want to make sense of the data, run analysis, build dashboards, run models? Okay, so the way we've structured our setup is like back in 2018 when we started, 2017, Airflow was a very natural choice to do this orchestration. So say we have like 100 plus analysts working on this data. They are divided into multiple teams, which we call projects. Data teams are like, for example, I will be assigned to project A, someone else will be assigned to project 2. And basically what we offer them is like a GitHub repo wherein they can like commit their workloads. And they have basically a BigQuery billing project, because there are limited cloud resources that we can use. So every team is assigned like a BigQuery billing project wherein their workloads are built. And then whatever workloads, whatever DAGs they run through Airflow. And yeah, and then basically that access, we have multiple like operators that we have, like say just running a BigQuery, maybe getting data from a Google Sheet to BigQuery table, or running anything basically. So this is how we started in 2018. And like, okay, coming to how like people configure DAGs, right? So not a typical profile of a data analyst or business analyst is like basically they'll know SQL very well. So we wanted to like leverage that, and not everyone would know how to write Python DAGs, and like every time they want to do something they would not have to write a Python DAG, right? It's too much to do, and it is also cumbersome. So the way we solved it is like using a custom DSL. So like, for example, yeah, this is called Toml, if you're aware. What happens is like, okay, the first part is DAGs, wherein you define the DAG. Say DAG ID is replay 25. You define a schedule of the DAG. Then you define the first BQ SQL, means it's an operator. It's like, it stands for BigQuery SQL, which is an operator that we have written on our own. Like basically, it's not something provided out of the box. So it has a DAG ID, it has a task ID, and it has a SQL. It can do anything basically. Create or replace table, select star, whatever you want to do. You just write the SQL, and it basically that's how the operator works. Then we have another operator, say another task says task 2, which depends on task 1. Again, write some SQL, right? So this is the setup that we created. This was again when we were working with Airflow. So this is not when like we shifted to Temporal. This is when, yeah, we were working with Airflow, and this is how basically people used to configure DAGs, right? You would simply define the DAG, define what you want to do, define the operator that you want to use, and like run SQL. So once they used to like commit this via a GitHub repo, and then in the background we had a framework which will basically convert this into Airflow DAGs, and then schedule it and run it on Airflow. So this was important to do because, as I said, like not everyone would like know how to basically write Python DAGs. So this is a wrapper abstraction we built for our users. Now Airflow provides this really nice UI. This is a really old screenshot I got from Google, but because we were no longer using Airflow. But basically, they provide a really nice UI to manage DAGs. This is kind of important because Airflow, Temporal, out of the box, will not provide this UI, right? People would not be able to like trigger DAGs, see logs, or like change schedule easily on the go. So this is kind of important. I put this because I'll explain on how we solved this when we moved to Temporal, because this is not something that is provided out of the box by Temporal. Now, like, why did we move from Airflow to Temporal? So we, just for context, we use Cloud Composer, which is like the managed offering that GCP provides. And as teams started getting bigger and more workloads and more DAGs getting started added in the system, one cluster was not enough to manage the workload. So we had to spin multiple clusters, and sometimes there was more load on one project, so we had to shift those projects to another cluster. And it was a complete mess because we are not able to scale with the growing demands of the organization in terms of like how many workloads you are running. The other was issues in scheduling. So say, this is like from our personal experience, say we had like 200 DAGs running, scheduled to run at the same time. Some of them did not used to run, and it used to cause issues. So maybe there was some implementation at the time in Airflow that caused this, but we were facing these issues. Sorry. Yeah, and then we were looking for solutions on what can we replace this with. Okay, so this was the checklist that we were looking for, like when we were trying to migrate. So it should be scalable, it should be resilient and fault tolerant, and it should have fault tolerance. It should have state management because say the task say gets killed in between, it should be able to resume from the point it failed. And support for custom operators. So Airflow provides this really nicely, wherein you can define your own custom operators. Say someone wants to hit some API and get that result stored in the G Sheet or a BigQuery table. So people should be able to write their own custom operators if they want. and basically ability to schedule, disable, trigger DAGs on demand. So this was the things we were looking for when we were looking for any alternative. And actually Temporal ticked most of the boxes. Some of them we figured on the go. Uh, One more like caveat I want to add is like we were basically when we like started adopting Temporal, it was not that okay we really wanted to replace Airflow, but when we like saw the technology, we thought that this can be used actually at various places in our organization. Different services, different businesses can use Temporal. So and we thought that okay this will be a very good starting point for us to try out Temporal so that the developer community within the organization can get used to it and then explore other projects that can leverage Temporal. Okay, so this is how we started. Then, like, how did we like make the move? So, like, say we have users, right, who basically are divided into multiple teams, right? They have their own GitHub project wherein they commit their workloads using the DSL that we discussed earlier. So, say I commit, I run a DAG. I want to run a DAG. I go to GitHub. I create the DAG using DSL. It goes to a CI pipeline on Cloud Build. We validate all the things that, like, okay, there are no cyclic dependencies and all of that. And basically, then we zip the configuration of the DAGs into a cloud bucket. And then, okay, this is where actually Temporal comes into the picture. So, okay, there is a system workflow that basically gets all the configurations of the projects. Like right now, we have like 150 data projects running. So there is a system workflow that gets changes from the buckets, Google Cloud Storage buckets, and basically, we'll get in the next slide. So this is basically the gist of like the whole, the crux of how we like replace, how we like kind of know how we like all the use cases, all the features that Airflow provided. How did we like manage to do it in Temporal? So as you said, like as in the previous slide, as we saw that this system workflow basically gets the updated configs of each of the projects, which has like DAGs and tasks. And then we basically have a workflow, a temporal workflow for each project. Say there are 150 projects running right now. So we have a workflow for each project. Now what that does is, so system workflow, a system workflow basically understands if there has been any change in workflow A, it will signal workflow A, and then workflow A will see, okay, workflow A might have like 5 DAGs, and the 6th one got added. So workflow A will basically start another DAG, start another workflow, which basically represents DAG 6, right? So project A will signal the cron workflows. So DAG, sorry. So basically, say DAG 1, DAG 2, DAG 3 is basically a representation of the DAG as a temporal workflow. This is not the actual run of the workflow because that happens at the end, which is the child workflow. But this basically is representation of the DAG, right? We'll have added code snippets which we can go through to understand in more detail. But basically, there's a system workflow which signals the project workflow. The project workflow will signal any changes on the DAG workflows, and the actual run of the workflow happens as a child workflow, which gets triggered from this like cron workflow. This works beautifully well because like it might sound really complicated, but if you take a look at the code that I'm going to show, it's like just few lines of code. Okay, for example, this is the system workflow, which basically just reconciles project configs from GCS buckets. And the reason we just loop it over 10 times is like we don't want to like just event history should not get bloated. It should have like minimal event history. So we just loop through 10 times and then again start the new workflow. So this is the system workflow. Now again, a project workflow, as I said, it waits for the signal from the system workflow for any changes pushed to the project, right? And once received, it basically does 3 things. So start any DAG workflows that for the newly added DAGs. Say someone actually created a new DAG, so it's the job of the project workflow to start a new workflow for it. Say someone removed a DAG from GitHub, right? They don't no longer want it. So the project workflow will terminate DAG workflows which got removed. So the way we do this is like we list the workflows using like temporal APIs, and then we determine, okay, like we see, okay, there are 5 DAGs in the GitHub repo, there are 6 here. We just take the diff and remove the ones that have gotten removed. We just terminate the ones that got removed. And then say someone changed the schedule from daily to weekly for any DAG, then this project workflow will signal that DAG workflow that it has gotten changed. So the way it looks is, okay, okay, we loop through it, say 10 times, for example, just for the same reason. We don't want to like get the event history bloated. Okay, it updates DAGs, which does those 3 things. Okay, adds a new workflow, removes any terminates any removed workflows, and signals any DAG that is changed, right? So if you see the last point, which is workflow.signal, so this is the main part. Like if something gets changed in the workflow, someone commits something, we signal this workflow, and then it gets unblocked. Say on line 67, it is waiting for the signal to the event to get set, then it gets unblocked, and then again loops through and does it over and over again. Okay, now the DAG cron workflow, which is an actual instance of the DAG, right? So again, it waits for the signal from the project workflow for any changes to that particular DAG. Say the schedule get updated or any change, right? Once received, it updates the sleep timer based on the updated cron schedule. So say it used to run every day initially at 2 p.m. Someone changed it to 3 p.m. So this DAG cron workflow will update the sleep timer so that it runs at 3 p.m. right? For example, then it actually triggers the actual execution of the DAG as a child workflow based on the schedule, right? Okay, we'll see how it looks like. This is like kind of like really, I think, nice. Personally, I like this a lot because say on line number 119, for example, it basically waits for 2 things to happen. It either waits for the, say it is 1 p.m. now and the DAG is scheduled to run at 1 p.m. So it waits for that time, or it waits for someone or for the schedule to get updated. Say, yeah. So this line number 119 basically waits for 2 things. Anything that happens first, it again goes back to the loop. So if the schedule get updated, we just set the event again so that the workflow gets unblocked and it goes back to the loop again. And once the actual time comes, once the timer gets exhausted, like then we actually run the workflow, which is like line number 125, which is the actual instance of the DAG being executed. Okay, now this is the actual DAG run workflow, which is the actual like execution of the DAG. So what it does is it gets the DAG definition from the toml that we have. It creates a graph of tasks based on the dependencies between them. Like say task 1 is dependent on task 2, so it creates a graph and start activity for each task accordingly, right? So each task is basically an activity that runs, and it gets completed when there are no tasks pending. I don't know why these numbers are 1111 because I remember. Sorry for that. Okay, this is how it works. So it gets the tasks, and we implement a class called task runner, which will topologically sort the tasks based on their dependencies. And on line 142, it gets, okay, what all tasks are ready to run depending on the like based on the dependencies it had. So if task A was dependent on task B, and task B is completed, so in ready task you will have task A to run. So so for each ready task, we actually trigger an activity, run task, and like pass the task configuration to it. Okay, as I told initially, like we have this Airflow provides a really nice UI, right, to do all of this, right? So how do we like make our users have the same experience with Temporal? So we built this tool called Dagman. Stands for DAG Manager. So this is how it looks. So basically, we built a custom UI on top of Temporal, which has its own database. So every time a workflow runs, an activity runs, we maintain a cache layer in MySQL, which will store the recent runs of the workflows, which will store what is the status of that workflow of each instance of the run of the DAG. So yeah, this is how we built it, and some advantages that we got from this is like because cloud costs are a thing now, and we really want people to like know how much their DAGs are costing. So we added like all the cost also in this. So if people are, by mistakenly someone has run a really large workload, they should basically know from here that, okay, this DAG is costing a lot, so you can review it. So these are some added advantages that we got because we have our own custom UI and we can like do anything with it now. So we tried to replicate the similar experience that Airflow had, which shows the DAG ID, the schedule, the last successful run, and the recent runs, right? So here we can also like enable or disable a DAG, just like Airflow had. Okay, so if you go to any DAG, for example, if you click on any of these, you will see the dependencies between those DAGs, right? Okay, BQ sync is dependent on something. In this particular instance, like both are independent, so they can run independently. Okay, yeah. So basically, similar to Airflow, we show all the recent runs, and this is actually not powered through Temporal APIs directly. As I said, we have a cache layer that after every activity run, we actually store the status of the activity and how much time it took, how many attempts it took. Okay, now we also want to show logs, right, for the DAGs, right? So, so when you hover on a particular square box, you actually can see the logs for it. Let's see how we also did that. Okay, logging. People would not say if a task got failed, right? People wouldn't want to know the reasons for it. So the way we did it is like for every log line that gets logged, we actually label it with the DAG ID, the task ID, the run ID, and the workflow ID. So whenever people click on view log, we actually apply those filters on the stack driver and just show the logs for that particular task. We'll talk a little bit about journey to Temporal Cloud. Actually, we have been using like Temporal since a while now, but it started with Cadence initially in 2020, like mid 2020, when we actually did not have Temporal established as much, and we did not even have like proper SDKs. So for like good 1 year, we were using like unofficial Python SDKs. I think there was a person called Firdos who used to maintain this Python SDKs. So in 2020, we used Python for activities and Golang for workflows, because at the time, Python did not have good support for workflows. So we thought, okay, let's use like Golang for workflows and Python for activities. Then in 2021, we observed that and there is more activity happening with Temporal. People are more engaged with Temporal, and there is a good roadmap that Temporal has. So we decided to make the switch to Temporal. Again, so again, the same setup, we used Golang for workflow and Python, an unofficial SDK, it was there. It was not actually fully launched. So we used Python for activities. Then when we moved to cloud in 2022, we moved completely to Python because the SDK was really stable. Again, the reason we moved is, again, Dagman started as like one project, but after that, a lot of people started adopting Temporal for multiple use cases, and it became really hard to, like maintain observability at scale, how to run Temporal. We were actually finding it challenging. So, and Temporal Cloud was the best solution to like overcome that. So actually, it's been like almost like 4.5 years that we have been using Temporal, like since the Cadence days, actually. It's been wonderful. Okay, I'll just briefly talk about what other projects we have that use Temporal. So we have this order payment lifecycle wherein a customer like places an order, payment confirmation happens, and everything after that, say the item gets cancelled, the return request is raised, or the return gets accepted, the whole payment lifecycle is actually managed as a Temporal workflow. CRM notifications, wherein we send notifications to like millions of our customers, and that whole workflow is actually managed using Temporal. This happened like just last year that we built this solution on top of Temporal. We have our loyalty program. So all the subscription that happens, payments that happen every month or every year, depending on the plan. So that happen, via a Temporal workflow. Order processing. So in Noon Food, a lot of our external integrations that we have in Noon Food actually run as a Temporal workflow for managing the entire life cycle of the order. If we talk about scale, like right now we run close to 3 million workflows daily. and we have like 10 plus use cases on Temporal Cloud running right now. It's been working really well. I would say that I wanted to give a shout out to the Slack community and people and folks who work at Temporal, and also other people who are very active on Slack. It's been really helpful for all the issues that we have faced in this all 4 years. They were actually really instrumental in like helping us get where we are right now. Thank you, and I'll just give you a quick demo on like how Dagman works, if it's okay.
Let's take a quick look at Dagman. So the wrapper, the UI wrapper that we built over Temporal to manage your DAGs. So here, basically, for a project, you can see all the DAGs and their recent runs. You can filter by the DAG ID. So we'll filter by the replay DAG and see its recent runs and also the tasks that are included in this tag. If you want to know, select a particular task and only trigger that, you can just click here and like trigger tasks, which actually triggers a temporal workflow. Before that, it actually signals the DAG workflow with the task IDs that we select. So it runs only the task that you've selected. In case you want to like check the logs for a particular task, you can click on the log, view log, and see the error and basically debug and fix it. Uh, if you want to actually see the underlying temporal workflow, you can click on the DAG or on the task and actually go to the temporal UI and see how the workflow execution has happened. So yeah, this is about Dagman. We actually also show the daily cost. So this is not temporal cost, but this is the task. This is the cost of BigQuery, for example, right? The underlying data warehouse cost. So it actually also, since we built a custom UI, we could also highlight the cost. And then, so basically everyone using it will be aware of how much it takes to run a particular tag. So because this was possible because we have built a custom UI, for example. Yeah, that's about it then. Thank you so much.